In section 4 of this chapter, we will talk about combustion of alkanes. The learning objectives of this section are to describe what a fuel is, to explain why alkanes are good fuels, to describe the environmental problems associated with the use of alkanes as fuels, and to describe how these problems may be tackled. In this tutorial, we will describe what a fuel is and we will explain why alkanes are good fuels. Alkanes are quite unreactive. They do not react with acids, bases, oxidizing agents, or reducing agents. However, alkanes do burn and they will react with halogens under suitable conditions. In this section, we will talk about combustion of alkanes. When a saturated hydrocarbon, which means an alkane, burns completely in a plentiful supply of oxygen gas, carbon dioxide will form and water, H2O. So the reactants are the alkane and oxygen, whereas the products are carbon dioxide and water. Let's examine the combustion reaction of methane, CH4. So CH4, methane, will react with 2O2 gas, so it will react with oxygen gas to produce carbon dioxide and 2H2O, water. Of course, you must know how to balance a combustion reaction. The enthalpy of combustion of this reaction is equal to minus 890 kilojoules per mole. Let's examine the combustion reaction of the second alkane, which is ethane. So C2H6 gas will react with oxygen gas to produce carbon dioxide and water. The enthalpy of combustion of ethane is equal to minus 1559.7 kilojoules per mole. So notice that both enthalpies of combustion have negative values because a combustion reaction is an exothermic reaction. A combustion reaction will release heat to the surroundings. So combustion reactions give out heat and they have large negative enthalpies of combustion. As the number of the carbon atoms present in the alkane increases, the heat output will be greater. And for this reason, alkanes are important as fuels. So fuels are substances that release heat energy when they undergo combustion. And they also store a large amount of energy for a small amount of weight. So these are the first 8 alkanes. For example, octane C8H18 produces approximately 48 kilojoules of energy per gram when burnt. So when you burn 1 gram of octane, it will produce 48 kilojoules of energy, which is about twice the energy output per gram of coal. So when 1 gram of coal is burnt, it will produce approximately 24 kilojoules of energy. So again, fuels are substances that release heat energy when they undergo combustion, and they will store a large amount of energy for a small amount of weight. Examples of alkane fuels include methane, CH4, which is the main component of natural or North Sea gas, propane, which is a camping gas, butane, which is a calor gas. Petrol is a mixture of hydrocarbons of approximate chain length C8, and paraffin, which is a mixture of hydrocarbons of a chain length C10 to C18. So these are examples of alkane fuels of different chain lengths. Let's talk now about incomplete combustion. In a limited supply of oxygen, the poisonous gas carbon monoxide will be produced. So if there are not enough oxygen for complete combustion to take place, we will have incomplete combustion where carbon monoxide, CO, is produced, and this is a poisonous gas. For example, if a propane, C3H8, burns with limited supply of oxygen gas, it will produce 3 carbon monoxide and 4 H2O. So this is called incomplete combustion. With even less oxygen, carbon soot is produced. For example, when a Bunsen burner is used with a closed air hole, the flame will be yellow and a black sooty deposit will appear on the apparatus. Incomplete combustion often happens with longer chain hydrocarbons, which need more oxygen to burn compared with shorter chains. So, as the number of carbon atoms in the hydrocarbon chain increases, more oxygen will be needed for complete combustion to take place. If there isn't enough supply of oxygen, incomplete combustion will take place and carbon monoxide will be produced, which is a poisonous gas.